How to find the domain of a function. We have an example where the fx is equal to 5 divided by x minus 2. So to find the domain or the range where this function could be, we have to determine some conditions. Here we are talking about the, the function x minus 2 is a divider. So it needs to be greater than 0, because if this function should be different than 0, because when you divide something with 0, you don't get any value. So x minus 2 equals to 0. We have to avoid this. X equals to 2. So this particular value needs to be excluded. So I'm going to draw an interval from minus infinite to plus infinite. And let's say here is number 2. This will be an empty circle because we have to exclude the value, and everything that comes that is greater than 2, it's true for our function, because if we try to add, for example, x equals to 3, 3 minus 2 is 1, 5 divided by 1 is 5. And the same thing goes on the left. This area is also included. And to determine that, we can pick a value, for example, minus 3. Minus 3, minus 2 is minus 5. 5 divided by minus 5 is minus 1. And we have a value. So now, to determine the domain, we have minus infinite to 2. Number 2 is not included. And the other area, union. Sorry about that. Union, and we have the other interval. I'm not good at drawing it, writing with computer, but we'll try. 2 to infinite. So now we have the domain. This is one way to find the domain of a function. We'll try a different one. Let's try another example. Let's say fx is equal to square root of x minus 4. So when you look at it, it seems like no value should be excluded. But the square root of a negative number doesn't give you a value. So the value of the function x minus 4, this one, should be x minus 4 should be greater or equal to 0, because the square root of 0 is 0. Now we know. And now to determine the domain, we have to equalize. So x minus, okay, we wrote one time that, so we'll write x should be greater or equal to 4. To see that in an x, I'm gonna draw the expansion. Let's say here is number 4. Now the circle should be incomplete. Now this should be complete because it's greater or equal to 4. So we have to include 4. greater or equal is this area. This is an easy example. So the domain of the function of fx is equal to, now we have to include 4, so we have to use quadratic understand to infinite. And this is how we find the domain of fx equal to the square root of x minus 4. Now let's take another example. Let's say we have fx, the function, equal to 2x minus 7 divided by the square root of x plus 3. Now, we know that x plus 3 needs to be greater than 0, because as we said earlier, a function, a negative root, doesn't give us a real value. But here now we have to consider, because the square root of x plus 3 is a divisor. So this value needs to be positive and different from 0. How can we determine that? So x plus 3 needs to be positive, greater than 0, and not equal to 0, because we cannot have 0 as a divisor. So x plus 3 is greater than 0, x greater than minus 3. Now, for the function we have as a numerator, here we can say that this is true for any value. But x needs to be greater than minus 3. So I'm going to draw a number line from minus infinite to infinite. Let's say we have minus 3. 3. Now we have x greater than minus 3. So the circle needs to be complete. No, it needs to be empty. And what comes from greater than minus 3 is true for our function, is the domain. Now how can we determine the domain? The domain of this function is equal to minus 3. We have round brackets, because we do not include minus 3, to infinite. Now, to try if our domain is correct, we can find the number 0. So 2 times 0 is 0, minus 7 is minus 7. 0 plus 3 is 3, and this value is equal for x. So for x equal to 0, our function is equal to f of 0 is equal to minus 7 divided by the square of 3. Now let's try a more complex example. So we have the f of x is equal to 3x minus 8 divided by x in the power 2 minus 9x plus 20. So we know the divisor should be greater than 0. So x in the power of 2 minus 9x plus 20 should be greater than 0. Now, to find the values, this is a quadratic equation. We have to equalize our function with 0. Here we come on an example where you have to find a double root, double value. X here should have a double value, no value, or one value. In most cases, it's a double value, but it can be no value at all. So here is A, here is B, here is C, the constant. So we know from a ready-to-go formula, we have the discriminant is equal to B to the power of 2 minus 2A multiplied C. So D is equal to 9 to the power of 2 is 81 minus 2, so 2 multiplied by 1 is 2, multiplied by 20 is 40. So we have the discriminant equal to 41. If the discriminant is greater than 0, we know we have two roots. So x1 or 2 is equal to minus b to the power of 2 plus minus 2ac divided plus minus here divided by, sorry, the formula is minus b plus minus the square root of the discriminant divided by 2a. So x1 is equal to minus 9 plus the square root of 41 divided by 2. X2 is equal to minus 9 minus the square root of 41 divided by 2. This is equal to, this is equal to. So to find that value, we need to use a calculator. So the values are minus 1.3 and minus 12.2. So to find the domain of this function, we need to determine the values 12.2 and minus 1.2. This is minus infinite and this is plus infinite. Now here we need to be careful. These values makes our function 0 because they are the roots of x1 and x2. So these are excluded. Now to determine the areas, we need to find some values that prove our function to be different than 0. So we can pick a value here, 0, 0. The power of 2 is 0, minus 9 multiplied by 0 is 0, and we have 20. So this proves our function. So this area here should be included. What about this area here? We can find a value that is minus 4. Minus 4 in the power of 2 is 16. Minus 9 times minus 4 is positive. So all this area is positive. So this area here is included also. What about this area here? So if this area here is included, this one should be 2. Because any negative value will give us a positive number or negative. It needs to be different than 0. Sorry, here we made a mistake, should be different than 0. So how do we determine the domain of this function? The domain of this function is equal to minus infinite to 12.2 minus 12.2. This not included. Union minus 12.2 to minus 1.2. This one is not included as well. Union minus 1.2 to infinite. And this is the solution we get from a complex function. But let's look at another example. And by the end, I hope you understood everything and I'm trying to be as clear as I can to help you with your exams or understanding the domain functions. Now, we have a function that is equal to the square root of x minus 4 divided by x to the power of 2 minus 25. We know that x to the power of 2 minus 25 should be different than 0. Here we have a quadratic example, as I told you earlier. Now, to find the roots, we need to equalize this with 0, and x power of 2 is 25, x um, is equal to plus minus square root of 25, that is equal to plus minus 5. But this um, these both values make the uh, the quadratic equation equal to 0, because 5 in the power of 2 is 25, minus 25 is 0. Minus 5 in the power of 2 is also 25, minus 25 is equal to 0. So we have to exclude x equal to 5 and x equal to minus 5, which should be different than both. But here we have another value. So as we said earlier, this value here needs to be greater than 0 or equal, because the square root of a negative number it's not doesn't get us a real value. So x minus 4 should be greater or equal to 0. X should be greater or equal to 4. Now we are going to draw a line number from minus infinite to plus infinite. Here we have minus 5, here we have 4, and here we have 5. As we said, these two values make our quadratic equation to 0, so those are empty circles. For any other value, this can have a real value or are not excluded any of the other values. But we have the other function. The x here need to be equal to 4, which isn't excluded from our quadratic equation, or greater than 4. So we have to go on the right. So this area here is our solution for our for the numerator, for the equation x minus 4. So now, how do we determine the domain? The domain of the fx will be equal to 4, so we have to include the number 4, to 5, we have to exclude 5 because it's not an allowed value for our quadratic equation. So we have circle brackets. Now we make union from 5 to infinite. This is our domain and this is our solution. Because we had to exclude 5 as it makes our function on the divisor equal to 0. So we have from 4 to 4, because 4 doesn't make our equation equal to 0, because 4 the power of 2 is 16, minus 25 is minus 9. And our function, you can divide with minus 9. You can divide by 0. Here, on the other hand, we have x, the square root of x minus 4. We cannot allow any negative value on this function, because if you take minus 3, it's true that the quadratic equation got a value, it's not 0, but our function x minus 4 becomes minus 1, and the square root of minus 1 doesn't have a value. Thank you everyone for watching. I hope I did a good job on explaining how to find the domain of a function. I will continue posting every week. If you got any inquiries or any example or any exercises from math, physics, or chemistry, you can comment on this video, or you can send me an email, which you can find on the channel description, and I will try to help you by finding you the easiest solution. Thanks everyone for watching, and don't forget to subscribe.